In the subsurface, acoustical energy is transmitted through rock in several forms, two of which are a compressional wave with elastic deformation in the direction of propagation, and a shear wave with elastic deformation transverse to the direction of propagation. The compressional wave travels through both solids and fluids, such as the mud of the borehole, but travels faster in solids than in liquids.
Therefore, a high porosity formation with liquid-filled pore space has a higher compressional travel time than a compressional wave traveling through non-porous rock. This is the fundamental basis of porosity determination utilizing acoustical energy.
The shear wave is transmitted effectively only in solids where lateral distortion can be perpetuated. Consequently, the shear wave is not transmitted effectively by drilling mud. It can, however, be measured. The compression, or C wave, moves faster than the shear, or S wave, in any single solid medium, rock in this case. Consequently, the compression wave always arrives at a distant point ahead of its companion shear wave, and is the wave used in conventional sonic logging as the measure of acoustic travel time, delta T, or script T, from source to receiver. The time period from transmission to detection of the first arrival of the compressional wave is the measurement made in conventional acoustic sonic logging. When an interface between a solid and a fluid is present, as between the mud and rock at the bore wall, two additional acoustical waves develop. These are a Rayleigh wave, which travels along the rock of the bore wall in an elliptical retrograde motion, and a Stoneleigh wave, which travels along the rock-mud interface, also with an elliptical retrograde motion. The Stoneleigh wave, or tube wave as it is sometimes called, is a result of interaction between the shear wave in the rock and the compression wave in the mud. The acoustical signal arriving at a distant receiver is a composite of all wave types, as shown here. The first arriving compression wave, the second arriving shear wave, next the Rayleigh wave, and finally the Stoneleigh wave.